welcome back to Learn as you explore, your go-to place for mBot2 tutorials. If you're a passionate teacher, check out the educator packs I've put together, linked in the description. This tutorial is a follow-on to the object tracking video. You should have completed the steps in that tutorial before following along this one. Alright, let's build on what we did in the last project. Last time we just printed the y-coordinate value of the ball on the screen. This time we're going to make the robot actually move forward as long as the ball is in the field of view of the camera, which just means as long as the ball can be seen by the camera. So load your previous program and save it as a new program because you don't want to overwrite the previous one. And this time I'm just going to call it Smart Camera Ball Tracking and say OK. First, we want to keep the same structure where we have when button B pressed, we want to set up the camera by turning on the fill light and then switching to colored block detection mode. Let's move this a bit out of the way so that we can focus on the core logic of the program here. Let's add a couple of variables outside the loop. First, I'll make a variable called max power percentage, and then I'm going to click on OK. Before we enter the loop, let's set the max power percentage to 25. This is the fastest that we want our robot to go. So if you want your robot to go faster, feel free to adjust this number. Next, I'm going to add another variable called max y coordinate and click OK. Now, how would we know what the max y coordinate is? In our last project, we saw that it is somewhere around 200. But to find the actual value, let's go to Google. Here, I just did a Google search for Pixycam 2 resolution color connected components. And from the AI overview, we see that the y-coordinate ranges from 0 to 207. So the min y-coordinate is 0, but more importantly, the max y-coordinate is 207. And this is what we will use in our program. Let's head back to mBlock now. Since we saw that the max y-coordinate is 207, let's set that variable outside of the forever loop. Change this to max y-coordinate and we'll set it to 207. We'll come back to these variables in a bit. Now let's go into the forever loop. We'll create a variable called ball y-coordinate. Go to variables, click make a variable and say ball y-coordinate. We want to set this variable inside the loop. This is because the ball y-coordinate is going to change over time as the smart camera tracks it. So drag it into the forever loop and we'll use the smart camera detected y-coordinate block to set the value. From our last project, we know that if the ball is out of range of the camera, the y-coordinate goes back to 0. So let's handle that. We'll add an if-else block here. Go to Control and select an if-then-else block and add it right here. The condition we want is to check that the ball y-coordinate is greater than 0. Go to Operators and get a greater than block. Go to Variables, use the ball y-coordinate here, and we want to check that it's greater than 0. So if the ball y-coordinate is greater than 0, then it means that the ball is in the view of the camera. Otherwise, if it's not detected, we will be in this else case, and we want to stop the motors using the stop encoder motor all block from the mBot2 chassis category. This makes sure that the robot moves only when the ball is detected and stops otherwise. Okay, so what do we want to do when the ball is detected? Right now, we're just printing makeblock and moving to a new line, which doesn't seem very useful. We want the robot to move forward. To do that, we'll use the encoder motor rotates at power block. So we can specify the power that we want for each motor independently. But how should we set these wheel powers? If we just set it to 50 like the default here, it's simply going to drive in one way throughout, regardless of what the ball y-coordinate is. So we want the wheel power to be dependent on the ball y-coordinate. One idea is to simply set it to the ball y-coordinate directly. But let's think through that. If the ball is far away, y is close to 0, the robot would barely move in this case. And if the ball is very close to the robot, y is around 207, which is the max y-coordinate value, and the robot would move super fast. That's actually the opposite of what we want. We want the robot to go fast when the ball is further away and slow down as it gets closer. So let's flip this around. We'll create a new variable and we'll call it wheel power and say OK. We'll then set the wheel power here. We want to set the wheel power to be max y coordinate minus ball y coordinate. Let's first do that and then we'll think about what that means. So because we want a minus operation, go to the operators category, use the minus block, and then we want to go to variables, use the max y coordinate as the first operand and the ball y coordinate as the second operand. Now let's think about what this means. If the ball is far away, ball y coordinate is 0 and the wheel power will be set to 207 minus 0, which is 207. If the ball is very close, the ball y coordinate is going to be 207 and the wheel power is going to be 207 minus 207 equals 0. So if the ball is far away, we get a wheel power of 207, and if the ball is very close, we get a wheel power of 0. That's much better. The robot slows down as it gets closer to the ball. But wait, look at that number. At the farthest distance, we're commanding a power of 207%. That's way too high. We only want the robot to go up to 25% as we defined in our max power. So how do we bring this down into the range that we want? This is where we introduce something called a scale factor. A scale factor just means divide by a number to shrink things down. Let's figure out what that number should be. We want to map 0 to 207 into 0 to 25. If you take 207 and divide it by 25, you get the scale factor. So let's make a variable called scale factor. Since the scale factor depends only on the max y coordinate and max power, both of which are constants, the scale factor is also a constant and can be defined before the forever loop because it does not change throughout the program. So go back to variables, let's use the set block. We'll change this to scale factor and we want to set this value to be max y coordinate divided by max power percentage. So get the divide operator and the first operand is max y coordinate and the second operand is max power percentage. Now let's update our wheel power formula. Instead of just max y coordinate minus ball y coordinate, we want to divide this whole value by the scale factor. To do that, let's grab a divide by block. We'll make this the first operand. This entire max y coordinate minus ball y coordinate will be the first operand. The second operand is going to be our scale factor, which we can get from variables. We can then insert this back into the wheel power calculation. Now, when the ball is far away, wheel power would be about 25%, and when it's close, the wheel power goes to 0%. Now that we have a good formula for the wheel power, let's replace the commanded powers by wheel power, which we can get from the variables category again. We can duplicate this block and paste it here as well. There's one last thing that we need to correct. From previous projects, we know that a positive power for the left motor makes it drive forward, but a positive power for the right motor makes it drive backwards. So we'll need to invert this. To do that, we'll get a multiplication block and we'll have -1 as the first operand and we'll multiply the wheel power by -1. This makes it such that a positive power makes the right wheel move forward and a negative power makes the right wheel move backward, and this becomes consistent with the left wheel. And that's it. Now when you hold the ball in front of the camera, the robot will move forward, slowing down as the ball gets closer and stopping completely when the ball is out of view. One final thing that we need to do is to change what we print to the CyberPy display. Instead of printing the text makeblock, we want to print the wheel power. But since we're calculating the wheel power below here, we need to move the print below the set wheel power block. To do that, let's take this apart for a bit, move this in between, and then bring it all back together. Finally, we can duplicate this wheel power block and insert it into the print block. Save your program, and now you're ready to upload. Connect your robot using the connect button. Make sure you're in the upload mode, click upload code, and wait for the program to be uploaded. That's it. Let's go test it out on the robot now. If you're excited to grab the mBot2 or any accessories, check out the links in the description. If you use the links, I may earn a commission at no extra cost to you. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.